Welcome and hello. This is a video exercise in WRIMS, and in this exercise, I've titled this one called Optimal Battery Operation. This is going to be a control problem where we have a battery and we're going to charge and discharge that battery to maximize profit over a 24-hour time period. What I have on the screen here is the problem statement, just as an introduction. Determine the maximum profit that can be generated by charging and discharging a battery connected to the power grid in a 24-hour period. And then the price of the power is going to be fluctuating. We'll see that coming up in a couple more slides. Okay, so what I have on this slide is my state dynamics equation. The energy, E, is going to start at 50. So we'll call this kilowatt hours. So E00 represents the starting energy. It'll be 00 representing the hour. That will go up to 24. So E01, E02, and so on up to E24, which I'm also going to set as a constraint to be the same value as E00, which is going to be 50 kilowatt hours. So how 1 hour's energy relates to the other. So for instance, the energy in the battery at hour 1 is going to equal the energy of the battery at hour 0 plus the charge in hour 1 minus the discharge in hour 1. So it's going to cost us money to charge, and then it's going to make us money to discharge. So it's the simple buy low, sell high situation where we want to charge when the rates are low and then discharge back to the grid, sell it back when the rates are high. I do have some constraints here listed down below. Battery capacity, the energy in the battery can range between 0 and 100. And we're starting it at 50 and we're constraining it to end at 50. And then the maximum charge and discharge in a single hour, T, is 20. So the minimum charge and discharge is 0, but then the maximum is going to be 20 kilowatt hours. And that's true for all 24 hours. Okay, on the next slide, I have the objective function, and this is just pseudocode. What I'm going to do is write out some Russell plus code so it fits into WRIMS a little bit later in this video. But right now, I'm just kind of explaining it. What we're trying to do is maximize the profit. So maximize the objective function value, which is going to be basically the sum of the expenses to charge and the amount that we can sell that energy back to the grid for. So we have a negative value here during charge for the price. P is the price, and then the discharge times the price for a positive value when we sell it back for time periods 1 through 24. Over on the right here, I have these are the numbers. I'm not sure what this is, but this is the price per kilowatt hour at each of the 24 hours of the day. Okay, so let's go ahead and get started. I've got my WRIMS up on this screen. The first thing we want to do when creating a project is go File, New, Project. Now for this, we'll go General, Project, click on Next. We'll give the project a name. We'll call it Optimal Battery Operation, and then uncheck this checkbox and then paste in the path to the project directory. I've got my project directory right here, so I'm just going to copy the path, Control C, then paste that in right here and finish. Okay, so we have our project listed. First thing I'm going to do is create my launch file. So right click on the project name, Run As, Run Configuration. I'm going to click on Russell/WRIMS application and then click on New. Okay, so up here, the name of the configuration, I'll just call it Optimal Battery Operation. For the main Russell file, we're going to call it main.russell. I'm going to put that in a run directory. I haven't created this yet, but I will. Right now, I'm just setting up the configuration. All right, so the DSS data, that's going to be in a DSS directory for the dvar, svar, and init file, dss.sv.dss, and the init file will be init.dss. Okay, and then down here for part F, I'm going to call this project, and then state, and then init. Okay, I only need one time period. What I'm going to be doing is grouping up all my decision variables into one time period. I'll show you what that looks like in just a moment, but instead of referencing a previous time period, we're going to allow the LP to see all the prices moving forward so we can solve it with full knowledge of the future price for every hour of the day. So we'll just select 1 month here. Unfortunately, we don't have the 1 hour option. That's all right. And then I'll select the end date to be the same as the start date, which is 1921. And then this will be October. So that's all set. Up here on configuration tab, I'm going to check on the Russell Plus checkbox. And then the far right tab, if you don't see it, it's the common tab. You may have to click this chevron button and then common, and then click on the shared radio button, click browse, and then select the project name, which for me is that top one. Okay, I'm going to click apply, and then our .launch file has been created, so I can close that for now. Over in my project directory, we have two files. So we have the .project file and then the launch file right here. We're going to add some more files right here just to represent the structure of our files and folders for this project. And what I want it to look like is right here. So we already have these two files, but I also need to create a few more files for the Russell files and then the DSS files. Okay, so that's what we're going to do for the next minute or so. So here we go. I'm going to go right click, new. We need a DSS directory, DSS. And then we also want a run directory at this top level. Run. Okay. I went into the run directory first, so let's just start here. I'm going to go new and then text document. This is going to be my main directory, my main Russell file, WRESL. Okay, and okay. And then in this directory, I have a system directory. So right click, new system. You can set up your structure however you want. This is just how I've been doing it, so I'm going to stick with it. And then I have a few more Russell files I need to add. Okay, off camera, I added these files. They're blank files ready for code, variables, constraints, and objectives. All right, let's go back up to the project directory. And then in the DSS directory, I want to create three files. The one that's most important we're going to be using is the dv.dss file. That's this one right here. And that is going to be where we get our decision variables. After the program runs, this is where it's going to write the output. Okay, there's for state variables if we're going to need it, and then init is right there. All right, let's go ahead and start building our model in the Russell code. So I'm going to go to run and then click on main. Here is the main Russell file. I'm going to Control O to open, go into system, and then open up these three Russell files as well. Okay, the first file I'm going to edit is variables.russell. So I'm going to Control V and paste. This is code that I had prepared, so I'm not going to waste time on the video typing it all out. But what we have starting off with is three state variables. First is E00. That's going to represent the energy of the battery at time period 0 at the start of the day. And then I'm going to set that to 50 kilowatt hours. And then I've also set state variables for the minimum and maximum charge. So E max and E min is what that refers to, and that is 0 and 100. So the battery cannot go below 0 and it can't go above 100 as far as its charge. Okay, I could set this to a higher number, but let's just go ahead and start with it at 100. After that, what I have are decision variables, and this refers to the energy in the battery after hour 1, after hour 2, after hour 3, after hour 4, and so on. This is a continuous decision variable. Now, the STD here just means that it's non-negative. The kind is charge, and the units are kilowatt hours. Actually, it should be hours. It's all right. I'm just going to go with kW. All right, further down here, I have decision variables for the charge and the discharge that occurs at each of the 24 hours. So C01, D01. C02 is the charge in the second hour, and D02 is the discharge in the second hour. So that goes all the way down to D24 and C24. For all of these charge and discharge decision variables, I have a lower limit of 0 and an upper limit of 20. So that means that if your battery starts at 50 kilowatt hours, it can't actually charge up to more than 70 kilowatt hours at the end of the first hour. Similarly, it can't discharge below, 20 is the limit on discharge, so 30 would be the minimum charge in the battery after 1 hour. You know what? This does bother me. I am going to change the units here, so just hang on a second. Click on replace kW, replace it with kW-HR. Okay, and replace all. Okay, there we go. Beautiful. All right, so that is it for our variables file. Next up is the constraints file. So if I scroll to the top here, this first constraint right here is basically saying that we have E0, that's 50, and then E24 has to equal the starting energy for the battery, which is also going to be 50. So the net charge or the change in the battery charge over that 24-hour period will be 0. It's going to start and end at the same number, which is 50. All right, down below here, we have current energy. So what I'm doing is I'm setting the energy in the battery equal to the energy in the battery at the previous hour plus the charge minus the discharge. So we saw this earlier when I was introducing the problem where we have E sub t equals E sub t minus 1 plus C sub t minus D sub t. That's what that is. All right, so that's true for all 24 hours. And then also I have a maximum and minimum constraints on the battery. We know that this E max was set to 100. So the energy in the battery at every hour from 0 to 24 cannot exceed the maximum of 100. And likewise, it cannot go below the minimum of 0. So that is it for the constraints file. The objective file is next. So what we're trying to do here is maximize the amount of profit that we can make by charging and discharging this battery, which is why for every charge variable, we have a negative price. And then for every discharge decision variable, we have a positive price. This is the same price, and I'll admit that this is a very simplified example with prices that fluctuates more than they probably do in real life. And there's also other simplifying assumptions, such as we're not considering any efficiencies in the charge and the discharge process. But anyway, here are those numbers for charge and discharge price, which is for all 24 hours. Okay, and the final file here is the main Russell file. What I'm doing is referencing the variables, the constraints, and the objectives in those three Russell files in that order. Okay, so it's just a single model called base. We're going to call that. It's going to run, and it's going to figure out what decision variables should be, which are going to be our charges, our discharges, and the battery energy for each of the 24 hours in our simulation. Okay, so I'm going to go ahead and hit save there. Let's go to RIMS, and then I'm going to actually right click and first refresh. Okay, that looks good. Here's our launch file. I'm going to go right click and then run as. Okay, that ran. Now we need to open up our decision variables file, which is where those results should be saved. Here's the project directory. If I go into DSS and then dv.dss, boom, here are the paths. It starts us off with the charge, and then below that we have discharge 1 through 24, and then finally below that we have the electrical energy of the battery for all 24 hours. So I'm going to go ahead and open up the paths here for E01 up to E24, and then click on the table. Okay, so we only have one time step. That's why there's only one row of data, but I'm going to expand it off a little bit. So we know we start at 50, which means after the first hour, it's 30, and then 40, and then 60, and then 80, and then 20. Notice that it's not changing by more than 20, and then it's 100, and it's 100, and take notice that it's not exceeding 100, so that constraint works. And then it dips down, it's discharging all the way down to 0. It's hit the minimum of 0, so that constraint looks like it's working, all the way to the final hour here, which is 50, which makes sense because we set the final energy to be equal to the beginning energy. I'm going to go ahead and copy this data onto my clipboard and then paste it into an Excel file. All right, so here's an Excel results tab that I have ready to go, and I just pasted in those numbers. The row down, I'm calculating the change in energy, and then the profit for that particular time period, and then the cumulative profit. So if I scroll down here, what we have is this blue line is tracing out the energy of that battery over the 24 hours. It starts at 50, it ends at 50, and you can see it does pop out at 100 and it bottoms out at 0, and it's also holding steady. This slope right here would represent the 20 kilowatt hours per hour. Yeah, so 20 kilowatts. And then like this slope here is not quite as steep. I think this is 10 kilowatts and 10 kilowatts. But for the most part, it's either doing a max discharge or a max charge for most of the time periods. And then down below that, I have my profit versus time. So over the course of 24 hours, you can see that the battery starts at 0 profit, and then it increases to what looks like about 17 or 18. So I have that number written down at the far right end of my cumulative profit, and it is 18. All right, cool. So we can maximize our profit for this scenario and make $18. So if I zoom in on my results table here, I've typed in $18. That's the profit that we can make in 24 hours. The battery starting at 50 kilowatt hours. The maximum capacity is 100. The maximum charge rate and discharge rate, where we buy the charge and then sell to discharge, is 20, and that's in kilowatts. All right. So what I want to do is run through two more scenarios and see how changing some of these input values will change the results and hence change the profit. Okay. So what I'm going to do in the next scenario, scenario 2, is let's change the max rate of charge and discharge from 20 to 30, and then see how that affects the charging and discharging and the max profit that we can make using LP. Okay, so I'm going to go ahead and save Excel. Let's go ahead and close the results, minimize DSS view. I need to go back to my file where no, the variables. Oh yeah. Okay, so on the variables page, if I scroll down here, I have my decision variables for charge and discharge, and the lower limit is 0, upper limit is 20. We want to change this upper limit to 30. So I'm just going to do a quick find and replace all, 30, okay, and replace all. See if that updated. Yes, so now we're upper 30 everywhere. I'm going to go ahead and save that and then rerun the simulation. So back to RIMS. Right click on the launch file, run as. Okay, very cool. Let's go to DSS view now. I'm going to refresh the catalog and then scroll down to the energy paths, E01 and E24. And then here is the table data. Okay, let's just do a quick observation. Yep, it starts at 50 and then it goes down to 20 so that we know it's doing a max discharge for that first hour from because the difference is 30. And then it looks like we only discharged 10, and then we charge 30, we charge 30, we charge 30, hold steady for a few hours, discharge 30, discharge 30, discharge 30, discharge 10, and then holding steady. All right, let's go ahead and paste that into Excel and then take a look at the plot. Here's our Excel again. Okay, I've got a table set up here for scenario 2. I'm going to paste in the numbers, and I also need to copy over these equations, just some simple math to calculate the change in energy, the profit, and then the cumulative profit. Let's scroll down here. Okay, so for scenario 2 now, that's in orange, and what we have is steeper lines and more charging and discharging, which should result in higher profit. You can see we start at 50. Oops, hold on. I need to update the data so it starts at 50. I'm one data point off. So scenario 2, edit, and then what I want to do for my data, it needs to start on column 3. Okay, 1 second. All the way to 27. Okay, and okay, okay. Okay, that's fixed. So we're starting, the orange line here is our scenario 2. Blue is scenario 1. We already saw that. And then we have just basically a steeper slope, which represents 30 kilowatts. If we scroll down to the profit table, it looks like a similar shape, but ultimately a little bit more profit. So what was 18 now looks to be about $23. Okay, let's go ahead and see what the actual number is here. It's going to be on the far end of my cumulative profit, and it is 23.1 here and there. I'm going to type that in, $23.1, which is cool. So basically by increasing the max charge rate by 50%, we have increased our profit by $5.10. All right, let's go ahead and do one more scenario. Obviously, we can do scenarios forever, but let's just do this. Let's increase the battery capacity to 200. And then after that, let's keep all the other parameters the same. So we're still going to start and end the battery charge at 50 kilowatt hours, but we're going to allow the charging to also be 30, just like scenario 2. Okay. So I presume that we're going to have higher profit and we're going to utilize more of the battery because there's just more to utilize with twice as much capacity. Let's go back to our Russell files. And then at the very top of our variables file, all we need to do is modify this E max value from 100 to 200. I'll click save, and then let's go back to RIMS, right click on the launch file, run as, run. Okay, that looks like it's done. So let's go back to DSS view, view, and then refresh. I'm going to select my 24 energy paths and then open up the table data. All right, here it is. So 80, 110, 140. It looks like we're topping out at 200 right here. Looks like we're going down to 0 right here. Let's go ahead and paste this into Excel and then see what that looks like. So here is Excel. Here's my scenario 3 numbers. Okay, let me zoom in. Okay, hold on. I got to fix the axes here. Format axis and then max 200. Okay, very cool. So the green scenario 3, this is what we just created. It starts at 50 and then it goes up to 200. It discharges all the way down to hour 15, which is 0. And then ultimately it's going to end the final hour here at 50 kilowatt hours, just like it started, just like the first 2 scenarios. Okay, let's scroll down here and take a look at the profit. I need to actually paste in the equations here to calculate the profit, which should be ready to go now. So let's scroll down to that profit plot. Okay, very cool. Looks like we went negative for a few hours, but we start at 0. We end at a higher number, which looks to be about 33. It's between 30 and 35. And it looks like it's a similar shape, but we're taking advantage of not only the higher charging rates and discharge rates of 30 kilowatts, but also the larger battery capacity of 200 kilowatt hours. So let's go ahead and actually get that number. It should be over here. Yep, here it is, 33. We'll go ahead and paste that in right here, $33. All right, well, this was the end of the exercise. What we did was create a simulation using optimal battery operation. We used linear programming to look ahead at a price table for all the hours of the day, and then using an objective function to maximize the amount of money that we could profit from by charging and discharging that battery, and then running through a few different scenarios by modifying the battery capacity and then the max charging rate and discharge rate.